In this video, we are going to do a piecewise function example involving limits. So I have this piecewise function, c of x, and the problem is I want to find the values of a, so notice in two of these pieces I have this unknown a, that make c of x continuous at x equals e. Alright, so I want to find the values of a that make my function continuous at this point. Okay, so the first thing that I want to note is what it means for a function to be continuous at a point. So c is continuous at x equals e if, and what I need is the limit as x approaches e from the left of c of x equals the limit as x approaches e from the right of c of x, and this needs to also be equal to c of e. So the limit from the left has to equal the limit from the right, and those both have to be equal to the value of the function at the point that we care about. Okay, so now we need to think about how we evaluate these limits. So let's begin with this limit as we're approaching e from the left. Okay, so if we're approaching e from the left, that means that x is less than e, but it's close to e. It's close to e because it's a limit, and it's less than e because it's approaching e from the left-hand side. That's why it's less than e. Okay, so let's think about what piece of the function we would use. So in terms of my function, if I were to just draw a number line, so the function has sort of these cut points at 1, and what I mean by cut point is that's a point where it sort of switches from one piece to another piece. At 1 it switches from the top piece to the middle piece, and then it switches again at e. Okay, so on the left-hand side of 1, we are using the top piece. In between 1 and e, we are using the middle piece. And then on the right-hand side of e, we're using the bottom piece. And that's based off of what our intervals are in this piecewise function. Okay, so if we're talking about this left-hand limit here, the limit as x approaches e from the left, we said that means x is less than e, so it's on the left-hand side of e, but it's really close to e. That means we are here somewhere, getting really, really close to e, but on the left-hand side. That means I'm going to use the middle piece. So we want to use the middle piece. Okay, so I'm going to write my limit, the limit as x approaches e from the left, but I get to replace c of x with that middle piece, which is ln of x plus a. Okay, let's try to do the same thing for this limit as x approaches e from the right. Let's determine what piece we're going to use. So if x is approaching e from the right, that means that x is greater than e, and that can only mean that it's one possible piece. That means it's definitely going to be approaching e from the right. It's going to be that, that's the bottom piece. So on this side, it's the bottom piece. All right, so let's go ahead and write the bottom piece, which is ax minus 4. Okay, and then finally, this also needs to be equal to what we get when we just plug e into our function. So the piece where I get to plug e in is this one, because I have an equal sign where the e is. So the middle piece again. So if I just plug e in, we get ln of e plus a. Alrighty, so now we've simplified it a little bit. I know what piece to use for each of these limits. Well, once I know what the function is for each of these one-sided limits, and now I do my first step with a limit, which is I plug in. If I plug in e here, I get ln of e plus a. If I plug e into this expression in the middle here, I get a times e minus 4. And on the right, I can simplify it, but let's just keep it as it is right now. So it's ln of e plus a. Okay, so I noticed that I see two of these ln of e plus a term, so I don't need to write it twice. Let's just simplify that ln of e plus a. So ln of e is 1, and then I have plus a. And this equals a times e minus 4. Okay, so let's continue to simplify. So let me add the 4 to the left, and that'll give me 5, and move this a to the right, and that'll give me a e minus a. And I'm trying to solve for a, so let's factor the a out, and I'll get a times e minus 1. And now I just need to divide e minus 1 over. So we get a equals 5 divided by e minus 1. So this value of a makes the limit from the left be equal to the limit from the right. So visually, when the limit from the left equals the limit from the right, I get a picture like this. Limit from the left being equal to the limit from the right, the graph sort of meets, but the limits don't tell me the value of the function at that point. So when we also specify that those both need to be equal to c of e, that means put a closed circle where those one-sided limits seem to be approaching. And that is now what finishes that definition of continuity. All right, in terms of our goals, we have finished learning goal 2, which is how to find limits of a piecewise function. In the next video, we will find a limit of a difference quotient. So we'll see these a bunch when we introduce the definition of the derivative, but we can actually handle them right now based off of what we know about limits.